But there are other problems, like how do you explain the results to a patient? How do you communicate your results to the clinicians? They don't understand like what's going on inside a deep learning model. They don't want to rely on it. But if you can like collect a very representative data set, like from a diverse population, maybe from multiple countries, and evaluate your deep learning model like as exhaustively as possible. Maybe you train your model on data collected in a few countries and test your model in a new country or a new clinical sites. It gives you more validity that the model is actually learning and performing well in the wild. So it may give some confidence to the healthcare providers that, yeah, it's probably doing right.
Yeah, I should try to answer this because our data set is very small.
Yeah, can you put the microphone closer or make sure it's on?
Okay. Okay. Uh, I think I should try to address this as well because our data set for this paper was very small. In our case, we certainly have we need to build the confidence in the clinicians, and that is why we are working with collecting more data. That is the main thing. Other thing is we are also developing, as part of the second stage of this project, we are further working on developing a interface for the clinicians where they can also see the weekly data for the patients, and we are going to work with multiple clinicians to understand their confidence in the system to build this further. So that they can also look at the data themselves when they are talking with the people. In our case, the interviews are after one month normally with the clinicians. That is why the recall bias comes into picture when the clinicians see this. So showing them the overall performance and the sleep data and various sensor data and their surveys at the time of interviews also builds a good confidence in the clinicians for these predictions.
Okay, thank you. Go ahead.
Yeah, that's a great question. Thanks for bringing it out. I want to add another thing that I learned when we were collaborating with a clinician who studies people with multiple sclerosis who has severe symptoms like pain and fatigue that they feel throughout the day. So the clinicians were telling us that think about like two person with MS, person 1 and person 2. And in terms of ground truth, they both reported high fatigue, 9 out of 10 on a Likert scale. And the next question that the clinicians ask is, describe your day. And person 1 said, oh, I wake up, I took a morning walk with my dog, I go to the gym, I do some exercise, I drop my kiddo to school, I come back, I go to office, and I do this kind of stuff. And the clinician is like, oh, but you are doing not that bad because you are feeling those fatigue. In addition, you are performing your daily activities. Whereas person 2 is like, yeah, I'm also feeling fatigue on a scale of 9 out of 10. But while describing the day, they are like, oh, I always feel so fatigued that I often need to take rest. I cannot even go for the gym to do exercise. I cannot go to the school to drop my kid and do those daily activities. So what is important to me actually is that in terms of ubiquitous application, we are focused more on this kind of prediction problem. So if we train a machine learning model, the model will say, yeah, person 1 is also fatigued, now 9 out of 10, and person 2 is also fatigued 9 out of 10. And that's an accurate model. But we also need to understand the underlying behaviors that may drive their symptoms or may change the symptoms. It could be worsening or it could be improvement in symptoms. So I think it's more important to look the nuances on such behaviors.
Yeah, because the patient got recall bias.
Yeah.
And,
Yeah.
Yeah.
Okay, that's good. And I'm also a bit curious about, sorry, just one sec.
Yeah,
I'm
yeah.
also a bit curious about the neutral gate, you know, like
neural gait, yeah. Well, because there are lots of sensors, to measure gait, but why you choose like mobile and put that in the pocket? What's the rationale behind that?
Okay, yeah. Thank you for this question. In our work, in addition to the inertial sensor, we also use the microphone sensor to collect the human voice. We want to use the mobile technology to solve the healthcare issues in the real world. Because we want the users can realize some healthcare goals in their everyday life, and I also would want to mention that the data collection of this mobile data is very challenging, because some patients they are not very familiar with the smartphones. When in the data collection, they may face many issues, and also our data collection is round the clock. We need to collect data from their daily life, so they also have some privacy concerns. They do not want to share their gait data, voice data, so we need to communicate with them. So I think this is a very challenging process. Yeah.
I see. Okay, we got some questions from the audience.
Yeah, I wanted to piggyback off of like the recall bias point, and I do a lot of work in mental and behavioral health, and we always talk about, we have imperfect outcomes, right? We don't have a lab test, and I think hearing actually a lot of this presentation where you observe gaits and you make an assessment, right? Or you observe other factors of a patient, this almost applies to actually kind of broader than mental and behavioral health as well. So my question is, as sort of technical or systems, we're building systems and technologies to predict these outcomes. What are ways that we can factor or think about like the imperfections of these outcomes, and how does that factor into our modeling approaches, and what could we be doing better as a community?
Sure, I can try and answer that, but it's a difficult thing, right? Mental health is already complex, and how do you? One of the things that that the community as a whole needs to move forward from is like this fascination with high AUC, especially when you're dealing with mental health, right? It's a complex problem, and you can't expect to get like 0.7, 0.8. You don't look at it in that regard, because we first need to fundamentally understand the issue, which even the psychologists who diagnose it are having an issue with, right? So there's the whole thing about whether SCID itself, like the structured clinical interview itself makes sense, right? And versus Arducian approach, where maybe it's a continuum, right? It's like things change, right? So having said that, like trying to like get right this fascination with like, hey, you gotta get this much accuracy, and you gotta like, so you can treat, I think, mental health work the same way you do other work, because there's so much variability, there's so much uncertainty, right? So I'd much rather be, if we like what Tanzim says, like moving slow, right? And rather than moving fast and breaking things, right? So I'd much rather see if we can focus on that sort of like fundamentally trying to understand what's going on. We have almost a decade of like mobile sensing research now. None of this is translating to anything, right? Why is that happening? Like, and venue like UbiComp is the best place to do that, right? So I can't speak from the system point of view. I think my colleagues here would be a better place to do that. But I just feel like there's an issue with us trying to like follow the trend with every other computing problem and trying to treat it at the same, whereas it's not simply that. It's not at all that, right? Some of the cases, some of the issues are more trackable than others, even within mental health, right? But when there's like high stake involved, it's just like relying on just like one or several of a performance values to sort of like I mean, get it that I don't think that's the point of it. But yeah, if anybody wants to talk about like uncertainty, building that into the system, yeah, go ahead.
Yeah, so I want to add some point to the mental health perspective. So I want to emphasize that we are never expecting 100% accuracy or advanced scores in our domains, because personally I feel like we are really hard to get very high robustness or the reliability, but it's definitely our final goal. So maybe we need to design a very long trip, or someone are doing personalization, someone doing generalization, and someone doing some technical challenges. For example, one thought I'm thinking is in our domain, the data sets collected is pretty. Many data sets get collected, and it's kind of wasteful because we can think about how to reuse it. And it's definitely maybe beneficial for our final goal that we can achieve higher and higher impact and kind of the reliabilities of our systems. But really our work at this stage is kind of more focused on, can we get some insightful information from our studies design, from our observations and data analysis. So yeah, so that's what part I think is super important. Yeah.
Yeah, I think further research is necessary on where do we go from the predictions the machine learning model are making. Like, if you provide this prediction to a patient, they don't have any actionable item. But maybe you can tell them, like, these are the resources you can explore. Like, if you decide to see a clinician, these are the options you can explore. Just empower them with different types of option. And one thing we are exploring for our lab is like building or using large language model which knows the insights about the predictions we are making, like what are the feature values, how the model is reaching to that prediction, and that LLM can follow up with the patient with their questions.
Okay. So to make them more like transparent, to improve the patient engagement. Yeah, to get any information you can get. That's great. So next question.
Thank you. And I think healthcare is quite a hot topic always, as always, and no matter mental health or physical health. So I would like to ask a general research questions. That is, how can you identify a research gap from what kind of perspective? Since there are many previous work, or still there are hundreds of researchers working on the same topics as you. So I would like to hear some of your research experience, maybe related to your work. Maybe something you will find that the previous work has no good performance, and you want to design a fancy model to improve it. And other perspective, I would like to hear your opinions. Yes.
I suppose that while I'm using the attention mechanism, I have read a lot of previous work that they also use RNN or such as LSTM, and I don't think that is the best model to represent the temporal dependencies inside the EEG data. So I would like to find some other advanced mechanism to represent that. So attention is one of my finding, and I also have some other insight of the third neural network of SNN, spike neural network. I think it's one of the main point that I may future to find out if it really suits the EEG data. And this some technical insight of myself, and that's all.
I think one point is you mentioned about make it interpretable and make it transparent to all stakeholders like clinician. and the users, because then that's a sustainable way if you can collect more data, if a user trusts it. Yeah, do you want to say something?
Yeah, in our case, it was very evident. For example, I think we should talk to the clinicians and the stakeholders or the patients what they need, and the clinicians are the best people who can tell. In our case, we're working previously on detecting predicting the person is depressed or not, and then as a natural next step, we talked to the clinicians and they suggested yes, we should try to predict if the patient will improve or not. So that is really helpful for them. If although we provide a slight, a little bit of good prediction, confidence, they are happy to use it, because if we can save some time for them in the treatment, it is beneficial for clinicians and patients as well, because the medicine takes time to show the improvements.
Okay, thank you. Well, a bit shorter time. Maybe one last question?
Yeah, last question. Why are clinicians the best people? Like, they've never been outside in the field, looking at people moving in the field. Like, I think we should be more theoretical and have deeper discussions with clinicians and push back and tell them, like, in the wild, things are very different than in your clinic or in your, place. Like, I quite honestly think that we should be much more critic and not just take clinicians' word and actually have a deep discussion on what can we really add with mobile sensing and with mobile data, and discuss the theoretical underpinning of it, not just automate things. So why are clinicians, like, what else can we do as engineers? How can we push back and tell, hey, clinician, you don't know enough about mobility and out in the wild, and actually go for something maybe simpler, not detect depression, but just detect social activity or something that's a component of depression. I don't know, what I wanted your reaction to this.
I want to add a point here. So there is a theoretical term called translation gap. So if we think about a spectrum, on one side of the spectrum, there are model designers, and another side of the spectrum, we can think about the end user. So for this session, let's assume that this end user could be a clinician or the actual patients for which the model is built for. So I think the best way to answer this question or to solve this problem in a bit is to reduce this translation gap with proper communication. And if we think about the stages of model development, there are 3 stages. One is we don't have the model yet. We're trying to collect data. We are trying to formulate problem. We normally engage clinicians at this stage. Also, we engage the clinicians at the last stage where we already have the model and we then give the model to the clinician to have their opinion. But we completely miss this communication between these 2 stakeholder groups, model designers and clinician, in the middle stage, which is the model development stage, where maybe we computer scientists, I normally try to refer them as math-savvy computer scientists, as you mentioned. They have this theoretical understanding of the sensor modality, the real-world condition. I think if we can properly communicate such problems with the clinicians, they can also reflect on based on their expertise, how those challenges can actually impact the certain physical condition or the certain disease that we are trying to model. So I think the goal should be to try to improve the communication and reducing the translation gap.
Okay, thank you. Well, a bit out of time. We could spend all day talking about this interesting topic. Let's thank the speaker again. We can talk offline. Yeah, okay. So don't forget, we still got poster sessions. You can, when you have your break, you can have a look. And thank you very much. Thank you. Thank you. Very good. Very good.